Oh, okay. There we are. Corona pandemic going on. Classes canceled, so I'm doing some YouTubes. Crazy Dr. Krause is back after being on the shelf for a little while. And this is about endocrine system, what you really need to know about the endocrine system. You need to know, and I'm looking at Super Simple first edition on page 254, figure 24.1, that comparison between the nervous system and the endocrine system. The nervous system communicates, commands, controls, coordinates, and provides consciousness. It does it electrically, very rapidly, virtually instantaneously. So I can put my hand up and put it back down and it happens bing, bang, boom. Very short duration of action. So it happens rapidly and then it's over with. Whereas the endocrine system communicates, commands, controls, coordinates, does not provide consciousness, and it does it chemically. Nervous system electrically, endocrine system chemically, very slowly or relatively slowly. That is, it may take 5, 10, 15 minutes or even longer, and then a much longer duration of action. In some instances, testosterone is a good example. That has an effect that lasts for decades and decades. You need to know the major endocrine glands. And I'm just going to read these from 255, pineal gland. And I'm doing these superior to inferior. I'd encourage you to always do things in a similar fashion. Helps you create learning neural nets. Helps you create synapses, which means you're likely to retain this for a longer period of time. Pineal gland. Hypothalamus, which is not an endocrine gland. It's part of the nervous system, but it has a significant and essential endocrine function. Pituitary, both anterior and posterior. Thyroid gland, parathyroid glands. There are 4 of them. Parathyroid glands, thymus gland, which is really part of the immune system, but also has an endocrine function. Pancreas, which has a dual endocrine exocrine function, and you need to know what an exocrine gland is, EXOCRINE, as opposed to an endocrine gland. One has ducts, one doesn't. One secretes into the ducts, into other hollow organs, like the pancreas's exocrine function are digestive enzymes into the small intestines. Endocrine glands secrete into the interstitial space, not directly into the bloodstream, but into the interstitial space. If I had my horn, it's at the office, but that's a honk, 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 into the interstitial space and then diffuse into the bloodstream. So endocrine ductless, exocrine have ducts. Make sure you know the difference between those. To adrenal glands, both the adrenal cortex and the adrenal medulla, they're right together, but they're actually 2 separate glands. And the ovaries in the female, dual endocrine exocrine function, and testes in the male, dual endocrine exocrine function. Know the 3 types, the 3 types of endocrine control. Humoral, glands secrete whatever the hormone is to a change in the blood level of a nutrient like blood glucose. When it gets too high, stimulates the release of insulin. That's humoral control. This is on the bottom of page 255 in Super Simple. Hormonal, glands secrete hormones when stimulated by other endocrine glands. In Crash Course, Hank Green talks about a endocrine cascade, and that's an example of hormonal control. And nervous control, glands release hormones in response to nervous stimulation. Like adrenaline released from the adrenal medulla is from nervous stimulation. Understand negative feedback loops. which always reverse the original stimulus, whereas positive feedback loops amplify the original stimulus. And a great example of that outside of the body are HVAC, heating, ventilation, air conditioning units that keep the temperature in a room, in a house, in a building at a constant, within a constant range, dynamic constancy. And that's what negative feedback provides, dynamic constancy, DC. And you can bridge back to chapter 20 to review negative feedback loops in super simple. And then a real emphasis on understanding all of the details of how the body maintains the homeostatic balance of blood glucose with beta cells in the pancreatic islets producing insulin and alpha cells producing glucagon. Insulin lowers blood sugar levels, glucagon raises blood sugar levels. You need to know how insulin lowers blood sugar levels and how glucagon raises blood sugar levels. And the homeostatic balance details for the homeostatic balance of blood calcium. Remember, we've talked about, or there are, and Super Simple talks about 4 specific ways or 4 specific places where calcium is essential. Bone strength, major storage site for calcium is bones. Muscle contraction, all 3 types of muscle, cardiac, visceral, skeletal, or striated. I'm forgetting one here. What's the one that I'm forgetting? Nervous system, synaptic transmission. Duh, hello, had a brain freeze. Synaptic transmission depends on the presence of calcium, and then blood clotting. So bone, muscle, nervous, and blood clotting. 4 areas where calcium is essential. You need to know the details of how the body maintains a homeostatic range, a dynamic constancy of blood calcium with parathyroid hormone produced by what glands, would you guess? Parathyroid. And calcitonin produced by the parafollicular cells in the thyroid. Oh, what else? Thyroid hormone. That's the last thing in chapter 24 here on page 259, is a great example of that endocrine cascade where the hypothalamus produces thyroid releasing hormone, which stimulates the anterior pituitary to release thyroid stimulating hormone, which stimulates, as you might guess, since it's called thyroid stimulating hormone, stimulates the thyroid to release thyroid hormone, which regulates cellular metabolism or the production of energy. We're back to CMCR, cellular metabolism, cellular respiration. And it might be a good time for you to bridge back to figure 1.5 in chapter 17 and review CMCR. Such an important process, dependent on the presence of enough glucose. One of the reasons that maintaining the homeostatic balance of blood glucose is so important. In fact, it's the primary reason. So review thyroid hormone with TRH and TSH. Understand that cascade of TRH and TSH being trophic hormones, hormones that stimulate other endocrine glands, and then will negatively feed back. As the thyroid hormone level goes up, then the hypothalamus and the anterior pituitary will turn down the secretion of TRH and TSH to maintain a dynamic constancy of thyroid hormone. Some good review questions and some activities. I think that's it. I'm going to run now. You guys keep churning to learn. See you next time. Bye-bye.